Hi Omega, this is Bill. I'm in my shop where I do a lot of my work, and I wanted to answer your question about where did this thing come from? What was the initial start of it? I could have written it to you, but I thought I'd actually show it to you to make it a little more clear. This is going back about 7 or 8 years, and probably the very first thing I did was something like this. And this is what everybody was doing at the time: aluminum and copper. Um, and if I turn it on, it's producing about a half a volt, which isn't very good. And even if I had 6 of these together to produce 3 volt, say a 3 volt light, which is what you folks have, it still wouldn't even light the light because there's such a little voltage or current coming out of it, very low amperage. So we go from this to this. This is just a benched prototype that I put together today. Each one has a cathode and an anode in it. You know about that. Let me show you how bright this one is. And I'm going to go ahead and ask Sue to shut off the light there in the shop. I'm going to turn this on. So that's what that looks like. This will actually get brighter the longer it's on. And this is a book I put here, a picture book, so it kind of shows you, what this thing can do. Again, it's not set to light up a whole room. Of course, it could be scaled to do just about anything. But I'll move the book out of the way too, so you can kind of see the space. If you'll show the picture, there you go. So obviously, someone would be able to read by this. They'd be able to study. They'd be able to sew or cook or anything. So that's basically the light. Now, this particular LED I'm using is the ones that I sent you that bag of. I think there's like 500 in the bag. So we'll turn the lights back on so if we can. So what I've done is I've come from this to this. That may not seem like a lot, but it is a lot. I'm going to show you something here. This is called the galvanic table. It's very, very, very important. This helped me to really get started. So what the galvanic table is, it's a list of material, mostly metals, and the carbon-based products, all the way from top to bottom. Most people started when they were making these, and I did too, with copper. And copper, say, is right here. And then they were putting copper with aluminum, and this is aluminum, and copper with zinc. So the spread was about this much, and it wasn't very, very bright at all. Well, when I got a hold of this, I found that magnesium was all the way at the top, and you can see how much farther over it is. And all the way down here at the bottom was graphite. Graphite is the same thing as what I sent you.
Put the paper down.
Yeah, is what I sent you, activated carbon. That's graphite. So this plus the magnesium, which takes you to the top of the chart, all the way down here is going to give you maximum brightness. Okay? And
Put it down.
yeah, and that's what that is. That's very, very important. This is called, there you go. So you can look that up on the internet if you want, and that will help you. But magnesium and graphite. And then all the way down here to graphite. This is called this table, okay? Cathodic table. All right, so you can see how bright that is. The main difference that I've been working towards is to get something that will last a long time. There are a couple of these kind of devices out on the market, not very many. They don't work very well. And their cells in here are only good for anywhere from 100 to 300 hours. To replace the cells costs anywhere from $15 to $25 a piece. And why would anybody do that? You can get a big battery and do that. It doesn't make any sense. This is the anode, and when I got them out of China, this was the size of it. This is 1 inch by about 5 inches. This is $2.50. What I did is I cut them in half, which is like the ones I sent to you. So those cost about $1.25 each. This system, as you see it, which is the same one that you've got there basically, will run for around 2,000 hours. This would run for $4,000, but it costs twice as much. 2,000 hours sounds real good. Use it for 4 hours a day, and you're going to get a couple years worth of usage. Replace those costs is about $1.25, so it would be $5 for everything. So the progression has been from this, thousands of hours, literally. I did over 200 prototypes to go from here to here. There's nothing like this on the market at all. There's nothing like it on the market at all. When I studied Malawi, I was really concerned, maybe that's a bad word, but I was astounded with just the lack of electricity, rural electrification. It's practically non-existent. This gives people light. It's not going to charge a cell phone. It is going to give them light, usable light, for up to 2 years to replace these cells here, which would cost very, very little. You're looking at 30, 40, 50 cents a month. So from here to here. Now, what you have is the same thing. I just did this today because I just wanted to show you this great light here. Okay? And there we go. Any questions, feel free to call me, contact me, you can Skype me. I'll be available to you at any time. We'll see if this thing happens or not. I did send this to David also. I think he should be aware of everything that's going on. And have a great day. Okay, bye.